So the final video in this section, we'll just talk about applied integrals. And really this just has to do with the AP exam. They're always going to put some type of extra explanation or something at the start of a problem, and they just told you to find an antiderivative or do this. It's not as difficult as if they give you a bunch of extra explanation and try to make it applied to some context. So you see a lot of examples like this. Grains being stored in a silo. Initially it's 50 tons of grain. Grains being added at a rate, blah, blah, blah. How much grain will it be after 12 hours? All right, so a lot of these ones have to do with this accumulation of change formula. And the formula looks like this. I'll just kind of write the general formula first. And the accumulation change formula says if I start at A, I can get to my function value at B if I add the integral of the derivative. All right, so what's that going to look like in this problem? I want to figure out my grain at 12 hours. So I'm going to start at 0 and add the integral of the derivative. But we know f of 0 is 50. And we know the derivative is dB dt is negative t squared plus 14t. And I guess it's dt instead of dx. All right, so this is all we're going to do. All right, just to save some time, this is just taking antiderivatives. Actually, I'll do that part for you. So the antiderivative of negative t squared plus 14t is going to be negative t cubed over 3 plus 7t squared. And then we want to evaluate that from 0 to 12. So we plug in 0, plug in 12. Again, I'm just going to have the calculator do that real quick just to save some time. I don't know how much time I'm actually saving by typing it in, and I get 432. All right, so that integral ends up being 432 to get my final answer of 482. All right, so that'd be the final answer. All right, but really, if they just told you to use the accumulation of change formula, that wouldn't be that difficult. Of course, you'd have to have the accumulation of change formula memorized. But knowing that, trying to figure out the next value of some expression, you have to use this accumulation of change formula. All right, so this one actually gets used a lot on the AP exam, so it's one of the ones we have to have memorized. Again, you can see this one, water is being added to a leaky tank. It's being added at a certain amount. It's leaving at a certain amount. Initially, there's 120. So if they're kind of giving you an initial value and they want to know some later value, chances are you're going to use the accumulation of change formula. So our water at time 30 is going to be equal to my water at time 0. And I'm going to add the integral of the water going in, and I'm going to subtract the integral of the water going out. Right, because if I'm adding water, that's an increasing rate. If I'm leaking water, that's a decreasing rate. And it says to round the 3 decimal places, so I can just type all this in a calculator. So my initial value is 120. We add the integral from 0 to 30 of 48 dt. And I'm going to subtract the integral from 0 to 30 of e to the 0.03 t dt. And when you put all that in the calculator, you get that the value at 30 is 1511.347. All right, so that's our final answer. But again, just using the accumulation to change formula, recognizing that you're starting somewhere and you're ending somewhere, so you add the integrals of the derivatives, and since all these are rates, they're derivatives. All right, so here's one for you to try on your own. Similar idea of people stuck in traffic and you want to figure out the future value. All right, so go ahead and pause the video and try this one on your own. All right, the answer that you should get at the end is 1,890 people. So we know what happens at 6 a.m. We have 500 people, and we add the integral of the derivative, which is the rate of change. All right, when we do that, take the antiderivative, plug in 8 and 6. Again, this part I kind of just had the calculator do to get 1,390. Chances are if this was on the AP exam, you had to do this by hand, but just save time in the video and stuff. All right, use the calculator, and that is our final answer. All right, so in class, we're just going to practice these applications of derivatives, all right, finding average values, going backward and forward from a position, velocity, and acceleration, and then just kind of word problems to kind of figure out what it wants you to do.